Okay, good afternoon all. Today we will discuss about behavioral modeling of Verilog HDL. So, the learning objectives for today's class is like we will discuss about different types of procedural constructs supported in behavioral modeling, followed by initial constructs, always constructs, and what are the timing controls used in behavioral modeling. Okay. So, this module or behavioral modeling will be of total 2 class. So, in this class only we will discuss this much aspects of modeling style. In another class we will discuss about looping constructs and other stuffs. So, now coming to procedural constructs. So, if till now we have discussed about data flow modeling followed by module instantiation, and in structural modeling again gate level modeling also we have discussed. So, all these modeling styles are concurrent in nature. Okay. They do not create any sequential design, or the execution of this model, all these modeling styles are happens in concurrently. So, now there is another constructs called behavioral modeling, under which there is a terminology called procedural constructs. So, that means all the execution will happen in a procedure, let us say one by one we can say. So, in a sequence it will happen. So, it will follow certain procedure. So, for doing procedural constructs coding, the primary mechanism is initial statement and always statement. So, in tutorial classes already we have discussed a brief about all these things, but in this module we are going to discuss in detail of behavioral modeling. So, the primary mechanism is initial statement and always statement. So, in a module we may have we have discussed like mixed type of modeling, in which we can write data flow modeling, behavioral modeling, or also structural modeling. So, similarly in a module we may have more than one initial or always statements. That means, we may have any arbitrary number of initial or always statements. Okay. It is not that only one always statements to be written in a single coding. Okay. So, all these statements, if you are having, there are many, let us say more than one initial or always statements, all these statements will execute concurrently. So, that means like if I told already in mixed type of modeling, we may have data flow modeling, we may have gate level modeling, we may have module instantiation. Okay. So, similarly if we are also, we may have behavioral modeling. Okay. So, in all this modeling style, all constructs will act concurrently. Okay. So, similarly if you are having more than one number of initial or always statement in a design, so all the statements will execute parallelly, but the body of the statements will execute sequentially depending upon what constructs you are using. There are few different constructs also, because in procedural constructs also we can go for concurrent statement. Okay. So, that we will see in future classes. The order of these statements are not important, because as these are concurrent in nature. So, you write in which order it does not matter, they will execute parallelly. So, they start executing at time equal to 0. So, assume that your simulation time starts at 0 time units. So, like your concurrent statements, initial or always statements all will start executing at time 0 unit. So, mostly behavioral model also allows us to write down conditional statements. So, all of we know about or acquainted with more with C. So, and Verilog is somehow similar to C type of coding language. So, because many of the constructs are similar. Okay. So, if you want to use the common constructs like if else, case for conditional operations, so those can be possible only under behavioral modeling. Okay. So, that means if you are using any case or if else, you have to include it with these two mechanism supported under behavioral modeling. Means if you are writing if else or case, it has to be written inside initial or always. You can't write directly initial, directly if else or case. So, initial, as the name indicate, initial and another is always. So, as the name indicate, always execute in a loop. So, it executes forever, you can say, depending upon certain conditions we will see. In contrast, initial will execute only once. Okay. So, initial will execute only once and it is used to create waveform. You can create waveform for writing test bench. You can initialize certain signal, because signal has to initialize if you are creating a waveform. So, it can be done, and similarly in always also used to always also you can use to create waveform which will be in a loop, that means it will create a continuous waveform, but apart from that always has a lot of more significance, like it is used to model designs. Okay. So, always we can use to model combinational design and also you can use to model sequential design. The only difference is that in sequential design the clock terminology should be there. Okay. That means, you know that without clock it will never become one a sequential design. So, many times I used to tell, like we used to have two types of always, one you will create we can say combinational always and another is sequential always. The difference is that in sequential always the execution will be done in positive edge or negative edge of your clock. Okay. So, wherever you are writing positive edge of clock or negative edge of your clock, so at that time one flip flop will be created after synthesis process and it will give rise to a sequential design, like flip flop based any design. Okay. So, if you are not writing clock or pulses, then it will create a combinational design. So, we can use always also to create combinational design. So, do not be confused that always is only used to design a sequential design. And again all the hardware should execute in a loop, means if power is on it should work in a loop, so that every time the output should be there. Okay. Because if you write the same combinational loop using initial, then it will only execute once. Once power is on, then it will execute once, it will do one set of counting if let us say counter is there or some sort of design, then after that it will stop itself, because initial execute only once. Okay. So, always has certain other importance than your initial constructs of behavioral modeling. Okay. So, coming to in detail of initial statement. So, an initial statement executes only once, this we discussed. So, execution will start at the simulation time which is at 0. So, if you assume that my simulation means instantly the your simulation start, at the same time initial block will concurrently act with other constructs in the code and it will start simulating itself, okay, or it will start executing itself. Okay. So, the syntax is very simple. So, you have to write initial followed by timing control is given in square bracket, then procedural statement. So, in this mostly you can see just like in behavioral modeling, initial is instead of we can discuss about initial or always, two main mechanism of behavioral modeling for procedural constructs. Then we have to discuss in detail of timing control, then we have to discuss in detail of procedural statement. So, if we are covering these three, then our behavioral modeling is almost over. Okay. So, today I plan to complete up to timing control. Procedural statements we can see in next class. Okay. So, in procedural statement it can have all these forms, like there are statements called procedural assignments which will assign the input towards output with a certain procedure. Okay. So, those are called as blocking and non blocking statement, followed by conditional statement like if else, you can say case statement, loop, and they are trigger event based trigger statement, sequential block and parallel block. So, sequential block is used to execute the block in a sequence like one after one, whereas parallel block can helps you to execute the block in parallel, means concurrently. So, both the constructs supported in the same behavioral modeling. Okay. Finally, certain user defined tasks or system defined tasks like the dollar monitor, you know. So, those things we can discuss. So, under procedural statement all these things we will discuss. So, syntax is initial, then timing control, then procedural statement. So, sometimes timing control may be optional. So, they have kept in square bracket. Okay. So, if you want to actually generate a time based waveform, then timing control is required, mandate. Okay. So, most commonly used procedural statement is called a sequential block. Okay. So, the sequential block is written within a statement called begin and end. Okay. So, if you are writing any more than one statement between begin and end, so it will force that particular block of statement to execute one after one in a sequence. So, that is why it is called a sequential block. So, again timing controls are classified into three types. One is called delay control. In short, I am discussing, then I will go in detail. Delay control, event control and condition become true. So, delay all these things like delay and event already we have discussed in our tutorial classes or lab classes. So, delay control is something like this, we did #10. So, which will help, which will wait for a certain time delay, you can introduce delay. Or event control we used to write down by using @ symbol. So, which will wait for a event to occur. Okay. So, it may be event in a particular signal or where, like @A also you can write down, okay, or event in a clock if it is a sequential design. Last one is condition to become true. So, in that case what we have done is we have passed a certain condition to after @. So, this is somehow used sometimes in level sensitive type design. So, we will see in detail. For covering initial and always we need to know a bit idea of delay and event. So, this has been demonstrated here. So, initial statement causes the procedural statement to execute once, that I know, that we know. Then after that initial statement start execution at time 0. Okay. So, depending upon the body of the initial, then it may end the entire execution of the statement later time, depending upon the body of the sequential block or what time period you or what time you have specified in the begin end block. Depending upon that it will complete its execution. That means, it will start the execution at 0 time units, but it will complete it depending upon the time specified in the body. Okay. So, it because as it is sequential, it will add up and finally, in the last time well after evaluating the last time, the block will be completed, execution of the block will be completed. Okay. So, this to remember, like if there are more than one assignment statement, so always you have to write a pair of begin and end. So, if there is no a single assignment statement, then no need to write begin and end. This already also sometimes we have discussed. So, few examples like range y initial y equal to 2. So, here this is an example with no timing control. So, it shows that y value will be assigned to 2 at time 0. So, there is no means since at time 0 time units when the simulation will start simulating or execution will start, at the same time without delay the value 2 will be assigned to y only once, because initial is given. Okay. And another thing we discuss at part of as part of your data path data type, like y as it is defined inside initial, it should be defined as a range. So, here as it is there is only one line, we have not written any begin and end. So, similarly in the next it is an example with a time control or timing control. So, where we introduce a time called #2 timing delay. So, now C will become or C will be assigned with a value of 1 after 2 time units, means initial statement start executing at 0 time units, but C will get the value after 2 time units depending upon the time specified in the body of the initial. Okay. Again it is single line statement. So, we have not written any begin end here. Okay. So, if there are more than one statement, then we have to specify a block of statement. At that time we need to specify those statements inside a begin end block. Okay. So, if you are writing begin end block, by default the block is sequential in nature, means execution will be done one after one, like C you know. Okay. So, next another example here is parameter size 1024. So, this is a sort of memory we discussed in earlier classes. So, range is one register and initial is one block. So, here to show two things, one is like here there are more than one statement in a initial you can say construct. So, we use a begin end. So, more than one statement. So, we use a begin end here. Okay. And another thing is, so if you are declaring any local declaration in the, like you can see index is a integer type data type declared within this block only. So, it is a local declaration within that sequential block. Okay. So, in that case you have to give a label to the block. This is a requirement. Okay. So, if you would have declared it like here in globally out of the begin end, then no need to give a label. Okay. So, this you need to remember. This is a small example code to initialize all the memory locations of you can say RAM size, RAM memory with a value of 0. So, how you can initialize memories to 0? They have used a for loop and accordingly they have used it. Okay. So, this is a small demonstration. Also, we demonstrate how to use begin end and where to use label. Then again before going to always, and again a simple example how to generate a waveform using initial statement. So, as the waveform is in vector form, so we have shown here also results in vectors. So, we have taken a delay parameter of 5 and again port A is a vector of 8 bit, then initial. So, more than one statement. So, one begin end block is there. So, as the begin end is there means it will execute one after one. So, first statement 1 will execute and there is no delay given here. So, if my simulation time is at 0, so at 0 time units I will get at port A of H20 or H20 x value. Okay. Then after that parameter value of delay like 5 time units, after 5 time units we will get HF2. Okay. So, now second is executed. So, 0 plus 5 is 5, sequentially the delay will be added. Okay. So, 5 plus 5 are 10, again port A is H41, then 10 plus 5 is 15. So, at 15 port A again will get a value of H0. So, this is a very simple example to generate a waveform. Okay. So, mostly initial block constructs is all about initial this is all about initial constructs. Okay. So, you have to just see how to use begin end, how to write different types of procedural statements or how to write parallel blocks, those things we will discuss. Okay. Only thing is to remember, if begin end then body is sequential in nature, one after one execution will be there and it will execute only once. So, like if it has executed only once, then it has end. So, that is a single. So, that is why it is mostly used for waveform generation or initializing certain value. So, you know that if flip flop is there, you need to initialize with a certain value, else it will drive to a unknown state or x state. Okay. So, in that means during that period this will be very helpful. You can initialize the output of a flip flop to 0 or 1, whatever you want. Okay. So, as initial execute only once. So, this property of initial we can't use to design use to generate designs, or using initial we can't generate hardwares like combinational design or sequential design. That is why to execute more than once always is suggested, okay, or always is used, right. So, now coming to always, again the syntax of always is almost similar to initial, only it will execute in a loop. So, always time control and procedural statements. Okay. So, it will execute it in repeatedly, and like initial statement always also will start executing at 0 time units. Okay. That means concurrently with rest of the constructs available in the same code. Okay. So, example is, first example we have taken like always with a timing control we have given like hash 5 clock is equal to not of clock. So, it will create a waveform with a time units of 10. This sometimes we discuss also earlier tutorial classes. So, initially clock may be assumed like it is 0, then after 5 time units it will become 1, inverted again after 5 time units it will become 0. So, this portion will continue in a loop. So, here we are getting a entire time period of 10 time units. Okay. So, it is a easy thing to remember, But one important note here is seeing to the second example here, in this example he has not given any sort of timing control. So, this is missing here. Okay. So, in this type of construct in always, as always loops indefinitely. So, this particular or always loops in a executes repeatedly. So, this particular type of code will loop indefinitely. Okay. So, that is why some sort of timing control should be there in always block. If it is a initial block, then it is not that much of required, because once it will execute and it will stop. But if it is in always block and you are writing this type of statement, where the same clock is again reused in input on after some expression changes in output also, then you must have some sort of timing control. Okay. So, that means this way of writing the code is not advisable. Okay. So, this is correct version of writing the code. Okay. So, this is one example of always. Then again, to show that how we can, if there are more than, here also if you will see, as there are one line statement, we have not used any begin end statement, and in this is another sequential block where we have not taken that timing control of, means delay as a timing control, we have taken like event control execution of always. Okay. So, that is why we have used execute cycle. This is a part of the some microprocessor code, where when execute cycle will be evented, that means there will be a change in value of execute cycle, which is a where, then this particular block will be executed continuously, repeatedly, because always is there. Okay. So, inside this block there is a case statement. So, this also demonstrate how we can use case in Verilog. We will discuss next class in detail. So, in this case there are different conditions, depending upon the condition some sort of tasks will be repeated. So, you can just see that some tasks defined in the some code like store, load, jump, maybe a instruction in a microprocessor. So, in different conditions those instruction will be completed or executed. Okay. So, if there is a more than one statement, you have to write begin and end. Okay. Sometimes I saw now in simulation tool they take case as a single statement. So, we start from here, end at here. So, begin end sometimes it is not required, but anyway it is to demonstrate that if by chance you find that there are more than one statement, you have to use one begin and end. Okay. So, and here again the body of the as begin and end will be there, the body of as this is a sequential block, the body will execute sequentially. Now, another example I have taken just to demonstrate only, like module D flip flop, clock D, set, these are my input, Q, Q bar are my output, which are again assigned values within another two always blocks. So, this Q bar is assigned or declared as a register type. Okay. So, here they have used one construct called wait set is equal to 1. This is something wait condition we use, these are level sensitive approach, we will see in the last slide, but this is not synthesizable. So, this code is only for simulation purpose, okay, to see how D flip flop is working in simulation only. Okay. So, always it shows that when this condition met, set is equal to 1 till it is not met, then it will be waiting. Once it is met, then Q will become 1 after 3 time units and Q bar will become 0 after 2 time units. Okay. And after that it will set the again it will wait for set equal to 0. Okay. So, if you will see, so when set equal to 1, so this particular flip flop is driving to a preset output, that means Q is becoming high. Okay. So, if I want that this will act as a D flip flop, then my set should be active low. So, that is why in another always module where he has taken here, this is one sort of timing control, we will see in the last, this is another sort of timing control where they have used negative edge of your clock. Okay. So, at negative edge of your clock, when set is not high, that is means it is active low or 0, at that time they are assigning the value of D to Q, and whatever Q value is that, their invert value is assigned to Q bar, because Q bar is Q. Understood? So, it is to show that like you can have more than one always statement in a particular code, and you can write model the sequential design by using behavioral level approach using always construct. Okay. So, weight is not synthesizable, this is level sensitive event control approach which is used for simulation only. Okay. And this is called edge trigger timing control. So, this also we will see in detail now. Now, next question arises, if there are let us say I am telling there will be more than one initial or always statement in the same block. Okay. So, now let us say assume that there is a coding where we are having more than one initial or always statement, then how they will execute. Okay. So, till now we have discussed that each statement starts executing at time 0. Okay. So, that we will see how it is executing. Okay. The same example I have written here. So, first is it is a test bench to observe the behavior of XOR, how it is responding for a certain inputs. So, register SA, SB and Z has been taken. So, initially I am assigning the SA, SB all these to a certain inputs. So, it is generally a test bench waveform. Okay. So, I am creating SA, SB with certain value of input like you can say here. So, let us say my it is to say that there is a initial block, there is a always block, another always block. So, as we discussed, all these three will start executing at the same time, that is your 0 time unit. Okay. But in order to start this particular blocks, like wherever delay is there, they will be executed after that certain amount of delay, but wherever @ is there, so that particular always block will though it will start executing at 0 time units, but it will wait for an event at the specified inputs. Okay. So, that means as I have written @ here, it shows that whenever there is an event at either SA or SB, then only this always block will be executed, but executes itself repeatedly. Okay. Similarly, in this line, whenever there is an event at Z, that means Z value changes either from 0 to 1 or 1 to 0, then this always block will execute. Understood? The summary is if in a single module, one module, if we are having more than one always block or initial block, then at the same time all will start executing. But if you have specified any event triggered items, then or event triggered functionalities, and then depending upon those events, those blocks will be starting execution. Okay. So, here if you will see initial, always and always will start executing parallelly. Okay. But after after initial begin, as this is begin end, this will again act one after one, means all these delays will be added. Okay. So, at SA equal to, so at 0 time units my SA is 0, okay, and SB is also 0. Understood? Then at the same time there is no event, so assume that my Z is also 0. So, after 5 time units, let us say here my SB value is at 1. So, now 1 is changing itself from 0 to 1. So, at the same time I have not specified SA value. So, SA will remain same as 0. So, if you will see at the same time always yet to understand, means always came to know that there is a event at SB, because at 5 time at 0 time units there is no event. So, whatever value is there, let it be there. So, at 5 time units there is no event at SA, but there is an event at SB. So, at that time this always block will start executing itself. Okay. So, what it will do? It will take the value of the SA like 0, it will take the value of the SB like 1, and it will XOR itself, and the value will be assigned to Z. Okay. So, here also additionally you can provide times delay. So, we have not given. So, at 5 time units 0 and 1 XOR will get a value of 1. Okay. So, till that period Z is not changed, till 5 time units Z also maintains the same value, there is no event happens at Z. Okay. So, when at 5 time units Z is now changed to 0 to 1. So, at that time this block again will be triggered, because there is an event now at Z. Okay. So, as there is an event at Z, then again this body of the block will start executing. So, what is that? It will start displaying the value of Z, SA and SB and the current simulation time. So, at time in percentage t. So, that is why this first line you can see at time 5 SA is 0, which is this one, SB is 1 and Z is 1. So, understood, this is how if there are more than one statement in the more than one initial or always block in the same statement, then this is how they will execute itself. Okay. Then after this at 10 time units, if you will see here. So, at time units B is not evented, but SA is changing from 0 to 1. Okay. So, and as B is not given any value, so B will retain the last value, that is 1. Okay. So, now as now SA is evented, now second time let us say SA got an event here. So, again this will start executing itself. So, that is we are observing an XOR behavior in a waveform. Okay. So, now again 1 and 1. So, output is 0 here at time units. So, now again Z is evented. So, you will see at 5, 10 and 15 Z has 1 event, means change in value from 1 to 0 or 0 to 1. So, that is why again Z will also execute itself. So, at 10 time units SA value, SB value and Z value will be displayed in the terminal window or console window. Okay. Similarly, at 15 time units again SB is becoming 0 here. So, that is why the 1 0 this will get a value of 1, means always first always block will be executed. Okay. Then depending upon the Z changes in Z, the second always block will also be evaluated and you will get the new value of SA, SB and Z at 15 time units. Okay. So, summary is that if there are more than one number of always block in the same code, then all will start executing at the same time, means they are ready for execution, but depending upon the timing control provided, they will start the execution. Okay. So, if it is event control, they will wait for a particular event to happen on the you can say this is also I told many times, it is called as sensitivity list at the rate some value. So, on the particular wires or signals, whatever event is happening, depending upon that always block will be executed. They will execute concurrently, but there will be a bit dependency will be maintained. Okay. So, this is about always statement. Now, coming to timing control. So, by this time you might have understood that there are two forms of timing control supported in procedural constructs or behavioral modeling of Verilog. One is called delay control, another is called event control. Okay. So, in simple, delay control will specify by using hash delay, hash some constant value like delay, but again instead of constant also you can pass expression, that we will see through examples. So, delay control example is always hash delay procedural statement. Okay. So, now example, first example always hash 2 t is equal to r minus 5. So, that means this block will execute itself and it will initially wait for a 2 time units delay. After that the value of r minus 5 will be assigned to t. Okay. This is one sort of timing delay and again another is how we already did this many times. So, after 3 time units w will get certain value, again 3 plus 6 9 w will get another value, for 9 plus 7 16 w will get another value. Okay. So, delay almost many times we did here in lab classes also. So, this is about delay timing controller, delay timing controls. Okay. So, now few different examples. A delay control can also be specified in this form, like it is not that you have to write a delay in the same line of the statement. It is not like, it is not always that it is a part of a assignment statement. It can be specified only like this, like hash delay semicolon. Okay. So, it will also wait for that specified delay, means the delay of execution, as this is there let us say in begin end and the delay is coming like hash delay, then it will wait for that amount of delay. Once that delay is over, then the next statement will be executed. Okay. So, one is here how to generate a clock. So, initially is around 50 time units delay will be there, then clock will become 0. Okay. So, that means say assume that here actually in this particular code example they have not given what is the initial value. So, let us say I am assuming like this is 0 1 x is my unknown value. So, let us say x is my initial value, at x let us say at up to 50 time units it will wait, then it will go to 0. Okay. Then again after that again 50 time units it will wait. So, up to that period means it will now become 100 sequential begin end. Okay. Then it will become 1. Okay. So, as it is always is a you can say repeated always, or it is a forever loop. So, again it will go up to like this, it will keep on going 100, 150, understood, 200. So, initial as it is not specified, it will start from don't care, but once it is specified it will come up with a certain valid state, like clock can't be don't care now, it is a input. So, it should be 0 1, or either before to this code you specify the what is the value of the clock, like 1 then 1 0 can happen. Okay. So, delay can take a form of like this also, that means it will wait up to that time units delay, once it is done then it will execute the next statement. Okay. It is not that you have to always specify it in a particular statement. Okay. Then another example is delay is not always constant, delay can be like we can define a parameter called period 100, then you can use after hash period by 2. So, these expressions can be can be part of delays also, it is not that always it is constant. And if there is no delay, then it is called as explicit 0 delay. So, that means the the assignment will be done instantaneous. Now, next type of timing control is called event control. So, event control is classified into two types, one is called edge triggered event control, another is called level sensitive event control. Okay. So, initially we will see edge triggered event control. So, whenever you are writing an edge triggered event control, that means either say clock based pauses or neges, and that eventing is happening, or there is a simple A B C D in that some event is happening. Okay. So, in that case you have to use always @ symbol, that is the syntax. So, an edge triggered event control is of this form, always @ of event then procedural statement. Okay. So, that means till now we have discussed initial always, now we are discussing the second part, and next class we will discuss this third part, procedural statement, what are the different form of procedural statement. Okay. So, one example is always @ of pauses of clock, current state is equal to next state. So, you can say this is a part of a FSM coding where the current state will become the next state only if the clock is attaining a positive edge triggering. Okay. So, that means clock value is going from 0 to 1, which is called as positive edge triggering. At that time the next value or next state will be assigned to the current state. Okay. So, this is one form. So, an event control delays the execution of the statement until the occurrence of the specified event. So, that means what we can do is till the event is not happening. So, this execution of always block will be delayed. So, that what I told you earlier, that always will start executing at 0 time units, but it again requires certain triggering to start its execution. Okay. So, if triggering is instance, then it will start at 0 time units, or it depends upon other parameters of the coding. So, like here if the poses clock will not attend, then the always block will not execute itself, it will suspend till the attainment of the positive edge of your clock. Now, next another example, you can also OR, means you can take two wires and you can OR it in the same defining in the same events, like pauses of clock or neges of reset. So, if it is OR means either of this is true, then the statement will be evaluated or executed. Okay. So, that means either clock is positive edge triggered or reset is negative edge triggered, that means it is going towards high to low. Any one will be met, means any one is true, at that time q will become 0. Okay. So, it can we can OR it in modern days, they are writing like with a comma, like you can write down positive edge of clock comma negative edge of reset, that there are two approach now. Initially they were writing OR, nowadays instead of OR they are writing like pauses of clock comma neges of reset. So, this comma indicates it is odd only, OR operation of two operands. So, this is all about your pauses of clock and neges of clock. When you are writing all these things as pauses or neges, it will create a sequential design, right. But there are certain situations where if you have not written pauses or neges, like I have written odd two operations like control A or control B. That means, if control A is true or control B is true, okay. In that case data bus output will become high impedance, like let us say Z. So, what it will create is, means if you will synthesize these two statements, the first will create a flip flop, but the second will never create a flip flop, it will create a combinational design. Okay. So, flip flop will come if only poses or neges word will be written. Okay. So, you can OR also the events. Now, coming to the definition of poses and neges. So, till now I told or we know that, let us say assume that this is my 0, this is 1, this is x. Okay. So, till now you know that if you are going from 0 to 1, it is positive edge, okay. Or if you are coming from 1 to 0, it is negative edge. Okay. But what they have done is, this is done. Now, you see 0 to x. So, anyway you are approaching from 0 to x, assume that it is in between 1 and 0. So, it is also assumed as a positive edge. So, similarly 0 to z. So, this can be also possible. This means if values are changing from 0 to x or 0 to 1 or 0 to z, those will be treated as a poses in the simulation. Similarly, if you are going from x to 1, any bit higher level, that is or z to 1, you can say, that is also treated as a poses in the coding. Similarly, in neges, just by seeing this I can say 1 to x or 1 to z is a neges, 1 to 0 already we know, and again x to 0 or z to 0 is a neges. Okay. So, to memorize, just simply put 0 x 1, you can memorize it. So, from some sort of lower value to higher value, when you are jumping, it will be treated as poses or neges. Okay. Another few example to show that, here if negative edge of reset is happens, then this block will be executed and the count value will become 0. It is something like you can make your count output reset to 0. Okay. And here if at the rate of C means, if C is there is an event in C, then Z value will become F. This is few examples we can you can see. So, this is one example, like delay I have told, you can write down only hash delay. Similarly, you can write down only at the rate event also. So, it will also make the simulator or execution of the statement to wait till the event is not happening. Once it is done, then it will switch over to the next statement. Okay. So, one simple example is given here, which is used to find out on delay of a pulse. So, out of a, it is a simple example, like if there is a duty cycle of this is there for a pulse, then which period is the on period. Okay. So, what they have done is, in starting they have taken at the rate of poses of clock, that means wait until poses of on the clock occurs. So, once the poses is occurring, at that time what he is doing, the some variable rises as time we are considering. So, time data type we have declared. So, rises is now $time, that means this current simulation time will be evaluated and it will be assigned to the rises, or it will be assigned till it is not attaining poses of clock. Once it is as attaining, then only this line will be executed. Okay. So, you can simply write down at the rate of event, it will also work, or hash delay, it will also work. Okay. Then after that again they wait till the negative is not happening. So, at the rate of neges of clock A. Okay. So, once negative is happening, what they are doing, finding out the on delay again, which is a time value, on delay is equal to $time minus rise is. That means, now what is the $time here, means simulation time, from that they are subtracting the initial value. Okay. So, that they can able to get this on delay period. So, like this you can just find out what is the, if there is a waveform is there, what is its delay period, or you can find out duty cycle and all, or period values. Okay. So, then they are displaying the on period in percentage time, and the value, the data type used is time for the identifier called on delay. Okay. So, this is to demonstrate that you can specify at the rate event individually, which will force the simulator to wait for a particular period, particular events to happen. And then the last slide is about timing control, which is the level sensitive event control. So, here mostly they use a construct called wait. So, this is again, as wait is not synthesizable, sizable, it will be used for only simulation purpose. Okay. So, wait till the condition is true, it will wait. If the condition till it is not true, it will wait. Once the condition is true, then the statement will be evaluated. Okay. So, the procedural statement executes only if the condition is true, else it will waits until the condition becomes true. So, then this type of construct will create a level sensitive event control. Okay. So, here you can see till sum is not greater than 22, it will wait. Once it is true or the condition satisfy, then sum will become 0, initialized to a 0. This is one example. Here if till data ready does not have a value of 1, it will wait. Once data ready is 1, then data will become or data value will be getting a new assigned value of the value, that is called bus. That means, bus value will be assigned to data. The last one is wait preset, like again you can only use wait and that particular variable or identifier. That means, the execution is simply delayed until the preset becomes true. Okay. So, individually you can use all the timing controls. Okay. So, this is all about your timing controls, initial constructs and always constructs. So, tomorrow class we will be discussing about what are the different procedural constructs supported in behavioral modeling of Verilog HDL.